How to set up an on-off heater control system with differential control and adjustment using a smart relay and an NTC temperature sensor. For this demonstration, I have created a miniaturized heating circuit using common components. The smart relay is a 24 volt DC unit. The heater will also be operating on 24 volts. The smart relay uses relay outputs. The relay outputs are rated for 8 amps, so you could control some heating elements using the smart relay contacts on their own, or you could use an interposing solid state or electromechanical relay. So I will go over the wiring a little bit. So we have an I/O fuse that supplies current to an NTC sensor. The NTC sensor signal is connected to input B. So it operates at 24 volts and it provides a very small amount of current to input B, and it's automatically converted to temperature as per the setup in the smart relay. If you didn't see my previous video on how to set up a thermistor for temperature readings, please view the video on how to do that. Our heater operates on 24 volts, as I said earlier, so we pick up 24 volts. If you follow my mouse down, it connects to pin 1 on Q1. There's a relay contact in there. It will close if required and deliver current through this fuse. It is a very common device used in millions of appliances, coffee makers, hair dryers, all kinds of industrial devices also. All heaters typically have some sort of thermal cutoff. I will show it to you when I demonstrate the actual setup. So we have 2 heater elements. In the case of the board that I'm using, I have 2 resistors in parallel for heating elements. Again, this is a miniaturized circuit, but it will respond identically. It's just scaled down. I've connected an LED in parallel with the heater, so when the heater operates, you will see the LED turn on. An LED circuit, if you build it from scratch, you have to have what's called a current limiting resistor. I have a 1K current limiting resistor connected in series with that LED. So the LED will turn on when the heater circuit is on. I now have a PLC style diagram open for the same circuit. You will see both wiring diagrams and schematic diagrams. And basically they are diagrams for the same equipment, but a wiring diagram tries to show the physical layout of the equipment. A schematic diagram just shows the workings of the circuit and the connections. If you look down on line 108, you have that 2-wire temperature sensor connected to input B. Has a description on it. And then over on the output side of the drawing on Q1, we have the heater arrangement connected. There's a dashed line drawn around all of the heater equipment to show that it is self-contained in one unit. This is the sensor that I will use. It's a 3-meter lead unit, IP68 rated. Alternatively, you can buy your own NTC sensors for pennies and solder your own leads on. Make up your own little sensors. They won't have an IP rating. You'll have to take care of how you install them. For a visual aid, I have laid out the thermal cutoff fuse on the diagram along with the 2 resistors that we'll have used for our heaters. I'm showing the resistor in series with the LED that will indicate when the heater circuit is energized. The circuit components will be connected to the interface board that represents the smart relay inputs and outputs on the SRT100 DAI Plus training board. The components are placed on a circuit experimenter board. I will proceed now with programming, then power it up and test. To save time and to keep this video from getting too long, I have the setup from the last video. Have the NTC sensor connected The calibration block is inserted, and we have a text screen that shows the room temperature, and I've adjusted the text to say that we will have a set point also in that text block. So let's put an output in the Q1 address, and I will double click on it and we'll change it to look like a heater. So we have a heater output on Q1. The block that we are going to use to control this heating system is called a trigger or Schmidt trigger. And the whole idea behind using a trigger is it has different on and off set points. It heats between 2 points. You do not want your system short cycling, and that applies to a cooling system also. You can use this block for heating or cooling. The output is digital, it's either on or off, and it's going to control the heater. We have 4 inputs. One of them is an enable function. If we don't connect it, it will automatically work. The first green input is the value to compare. So that's going to be our sensor that's measuring the temperature. And then the 2 other inputs are used to set up the actual temperature that you want the room to be at. So we have a on to off set point and a off to on set point. So that'll be your higher value. That's when you want your heater to turn off. So you can set those up for cooling or heating. So what I'll do now is I'll take the output from the calibration block, so that's our temperature, and I will connect it to the value to compare. So that we'll be comparing that sensor value to our set value, and that will turn the block on and off. In the Smart Relay software, if you want to learn or find out how anything works, you click on the device itself, the function block in this case, click on the help menu, and all of the information that you need for the Schmidt trigger, it has 2 diagrams, one for heating, one for cooling, is explained. I like to learn by doing in this case, and that's what we're going to do. We're going to get it to work and by testing and making adjustments. So what we're going to do now is connect a number block to this on to off set point, and that will be the temperature that we want the heater to turn off. So we go down to the input menu and we get ourselves a number block. You can put that in and you connect the output from the numerical constant to the on to off set point. And I will put a comment in there so we know what know what that is. Very important. Heating set point. And it is adjustable. We will allow anyone to adjust it from the front panel. And I'll show how that's done. And in this case, it's degrees Celsius, and you can set it up for Fahrenheit. It's no problem. You can set it up for operation in the US of A. Okay, I'll click OK. So that's the number, and we can start by putting a value in there if you want. Room temperature is 20 degrees. I'll just set it at 20 for now and click OK. And again, we'll be able to adjust that from the front panel. So in order to do that, we need to connect the output of that block to the text screen so that value is valid. We'll set that up in a couple of minutes. So we have basically we have our off setup. So when it reaches the room temperature, it'll turn off. But now we need to tell it when to turn on. So what we have to do is we have to figure out at what temperature to do that. In this case, I'll set it up so that the off to on set point, in other words, when the heater turns on, we'll set it up so that it turns on at 1 degree less than the desired. That way, again, as I mentioned earlier, it won't be toggling on and off and short cycling. We'll have a little bit. The reading that I've been doing tells me that most thermostats have a plus or minus 1 degree differential. So we'll just do it on the minus side. And then if you want, you can adjust it, or we can adjust it as required. So what we're going to do is we're going to get a little math block here. And it's an addition or subtraction block. And we'll take the output, the calculation output, and that will connect to our lower connection here off the onset point. And then we need to put a number input and a reference value. So what we'll do is we're going to take the set point value, and if it's set right now, we have it set at 20. We'll allow it for our off to on. We'll allow it to drop to 19. So we need to subtract 1 from that value. So that'll be a moving scale. So if we change the temperature, it will be constant. So we'll take that and we'll connect it to the terminal second from the bottom. And right below it, we will put a number. And that will be our differential value. So if we double click on this, and it will be adjustable. So under comments, because it's a differential heating system, we will call it our differential value. I could say adjustable, but we know it will be. So I'll click on that, and we'll give the math block a name, and it basically we'll call it subtraction. If we wanted to have an adjustment on the on to off, or on the heating, turning the heater off, we could do the same, but we would have to use an addition to expand that differential value. So we'll just go in here and I'll put a value of 1, which means that the heater will turn on. In this case, because my set point is 20, the heater will turn on at 19 and turn off at 20. But for comfort, you can adjust it. Or if you want energy savings and you want your unit to run less and you want it to have longer cycle times, then you can change that value. If you want to prevent someone from making adjustments to certain settings, in this case the calibration input, once it's set, if you want it to remain that way and not be tampered with, if you double click on the number block in the parameters window, if you check locking, and an operator will not be able to adjust that value from the screen. Now I will set up the screens. So we'll put some text in showing the room temperature and the set point, what the actual heater set point is. So we'll start with the temperature, and we'll just keep it simple for now. You can adjust that however you like. Temperature, and over on the far right it will be degrees C in this case, and the room temperature is this block number 4 here, this calculation block that comes from our temperature sensor through this calibration block right along here. So the next the next text block we'll set here, we'll call it heater and set point. So the set point for the heater temperature, and again it will be degrees C, and it's this one right here. Oops, yes, this one, 5, block number 5. It will go in there, and we have a little space up here so we can put our hour in there. We can get date in too or not. Oh no, we'll just stick with the hour. Okay, so let's go online. We'll download and go online. It is time to download and test. It's very important to have your communication set up. You actually want to do that before you even start programming. So I'll click on transfer up in the upper toolbar. If I go down to where it says communication configuration, I'll open that. And I'm using a USB to serial cable. You can use Bluetooth also, but in this case I'm connected through that USB cable. If I click test, it says connection successful. That means that we're talking to the controller. I'll click OK. Now I will transfer the program, and we're going to transfer from the PC to the module. It will give you a warning that it's in run mode, so if you're in the field and you're connected to a car wash, you will stop the car wash if you activate this stop command on the module. So I'll just go ahead and do that. I know it's safe. And we want it to automatically go into run mode. Again, you need to think about that. In the field, you may not want to do that. I'll click OK. And it's going to erase the program that's in there. Click yes, and it will transfer in. A very powerful function of the Smart Relay is using monitoring mode. If I click on monitoring mode, it will connect to the controller and it will supervise all of the input and output devices and display values. We can take control of the actual devices or function blocks in the program. We can also view the front panel and control the front panel remotely. So if I click on window up here, window, front panel, I brought up the front panel. We are actually reading the process right now. So I'll go over to the front panel and I'll adjust the set point. Right now the temperature is 24 and the set point is 20, so it's a little bit warm in here. Guess I've been working too much. I'll set it up to 30 degrees and we'll allow that temperature to increase up to 30. Now you'll see it change on this screen. Now I set it up to 30 degrees and we'll just let it increase to the set point. You'll notice that the heater is on in the program and the LED in the field, the red LED, is also indicating that it's on. We're at 29, we're at 30, it just shut off. It just overshot slightly to 31. Now we'll see how long it takes to turn back on and see what temperature it turns back on. You will notice as soon as it hits 30, it will not turn on. It will have to drop below 29 or at 29. We have that differential of 1 degree between the set point and the off to on trigger. Oh, there it goes. There's a slight delay. It turned on, it hit 28. It actually turned on before that and it dropped to 28. So we do have that differential control in there. Now it's heating back up. Now, with the scale of a building, obviously it would take a lot longer and it wouldn't respond as quickly as this, and it will shut off. There it goes. And that's it. That's our differential temperature control. And we can use that same function block for differential level control in tanks, pressure for air compressors, and so on.